Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
All right, welcome back everyone. This is my last moderation for today. I will be back on Thursday, but let me take a few minutes to thank the whole team of We Are Developers. They are doing an amazing job. I'm really thankful for them to reaching out to me in order to do this. So I'm really impressed by everyone, by the work of everyone. So I just thank you guys, whoever is watching this from the team. Great job, everyone. And our next speaker is going to be Brian Caldwell. He is the CTO and co-founder of Headspin. Headspin is a partner of the event of We Are Developers. And you can check out on the top again, on the 5th tab, you can go to Expo and head to Headspin or any other company and see what they have to offer. For example, Headspin, they have some jobs lined up. They're hiring at the moment, and they have some 30-day free trial of their product. So check if there's something you like. And but for the moment, let's welcome Brian to the stage. Hello, Brian. How are you doing this afternoon?
Hi, hello. Thanks for having me. Hi, everyone in Europe. Coming to you from Silicon Valley, United States, and really excited to be here.
All right, so you are going to talk about non-functional testing in user interface, backend services, voice interfaces, and media development. I'm not really sure what all of this ties together, but I think we are going to learn a bunch of all that now. So yeah, I would say I give the stage to you, Brian. Take it away from here. I'm going to add your presentation and off you go.
Thank you very much, and really excited to be here, and it's great to be back. And so this is a topic that's very dear to us at Headspin. The title of my presentation is Using Non-Functional Testing to Guide User Interface, Backend Services, Voice Interface, and Media Development. This is something that we've been focusing on for the last 6 years. And so what is non-functional testing? So it's really good to start by defining what is non-functional testing. It's good to start by contrasting that with functional testing. So functional testing, which we're probably all familiar with, is defined in terms of pass-fail. You give a certain input and you expect a certain output. Non-functional testing is defined in terms of actions, scores, and baselines. So it's less defined in terms of pass or fail. It's more defined in terms of quantities that are measured. And so with functional testing, the goal is within some reasonable definition of sample size, and eventually for the same inputs, the app eventually behaves the same ways. So if I tap through the navigation in the same way, the app should respond, the same way, test over test. With non-functional testing, the goal is to do as many samples as possible. So more samples are better. And for some action of the app or the backend, how does the performance or the quality or the usability or the reliability of the application compared to a target baseline? And so these metrics of performance, quality, usability, and reliability are really the non-functional metrics that we're testing. So for example, why would you want to do non-functional testing? So with functional testing, it's about making sure you achieve a certain level of correctness of your application. With non-functional testing, as you build and scale, you want to make sure that your key product areas continually get faster, more reliable, and a better experience. And the goal of non-functional testing is to really guide your application from something that meets the functional criteria to something that's really a 5-star amazing experience. And so when you look at, for example, reviews on app stores, customer feedback, a lot of the feedback is actually very much touching on the non-functional metrics we kind of went over: performance, reliability, usability. And with non-functional testing, you can set up a framework to guide your team to deliver consistently those 5-star amazing experiences. And so how do you get started with non-functional testing? And so the goal is to continually get faster, more reliable, and a better experience for your application. And the way to get started, what we've seen work repeatedly, is to create a framework that's a safety net using data to catch non-functional regressions. And so to say that another way, the way to start with non-functional testing is, and to get this safety net, is to really focus on the data. And the key difference that we see between functional testing and non-functional testing is the data. So non-functional testing involves a lot of data, which I'll cover different ways to collect and analyze the data in this presentation. So how do you get started with non-functional testing? You can actually start with exactly what you have right now. You have a lot of really gold nuggets that you can kickstart your non-functional testing that you're probably already doing. So you're probably already doing functional testing, whether it's manually or automated, and you have end users. So from these sources of data, we can start to distill a lot of non-functional test cases. And you need to bring in a little bit more skills than you're already using in your testing. So of course, the testing team needs to be involved with non-functional testing. It relies on functional testing and the idea of testing as a practice, but also bring in the data team and the product engineering team to help with the non-functional testing. And we see companies that move to create non-functional testing as a practice, really creating project teams, or as part of project teams, this competency of non-functional testing throughout the organization. So combining the skills of the testing team with the data team and the product engineering team, and really weaving this into the way that they build and they work. And the goal is to, with your non-functional testing, to create a non-functional regression safety net. And so as a very simple flow diagram, this is what the safety net looks like. So it starts at the very top with collecting more data. So the more data you have for non-functional testing, the more tests you can run. And so at the very top, there's a practice of, throughout your application, throughout your test, collecting much more data than you might be collecting right now. And we'll go into all the different ways you can collect data and implement the safety net. Once you have the data, the first step is to use that raw data to find hotspots where you think there could be an improvement to your application. So depending on what your application is doing, whether you're searching and pulling up results, whether you're launching videos on demand, whether you're running voice assistant applications, there are certain interactions where you think these are high risk. These could be, these are really the key interactions that we need to focus on. And for those regions and those specific hotspots, you need to find ways to measure specific questions about those areas in terms of the data that you have available, and also versus a baseline that you think is good enough for your team. And it's really interesting the way to choose a baseline. Sometimes the team has internally the idea of what's good enough for their team. Sometimes the baseline based on industry benchmarks. So, what is sort of status quo for the industry? What are other products doing in the industry? Sometimes it's an aspirational baseline. So for example, you really want this to be the standout feature of your application, and this is something that you want to focus on. Once you've identified ways to measure those specific questions in the baseline, then you need to start tracking those specific questions as you iterate. So as you release new builds, even in production, as new builds go out to end users, you need to track how those specific questions are changing over time, across different builds, across different locations, and across different backends. And this is where the regression safety net really kicks in. So once you've identified a certain question, for example, the time it takes to load the search results after I've entered the search query, if you find that it's getting statistically worse in a certain build or a certain time of day or a certain location, that's what we call a regression. So that's really an alert for your team that you need to stop and prioritize fixing this area. So for example, this was at one point a key area of your application. You made it better, and now it's getting worse. And so this is a real key area. If you want to continually improve and make forward progress, you need to take these regressions very seriously. And so when these alerts come and they're statistically significant, you need to invest time to fix them and bring it back to the baseline. If, on the other hand, if there is no statistical difference of your specific questions versus the baseline, then congratulations, you've made an improvement to your non-functional behavior. So by focusing on that specific question, quantifying it, and then measuring it versus a baseline, once you've achieved no statistical difference versus the baseline, you've made a positive improvement in your application. And now you can iterate from there. You can look at a new area or a new aspect or a new product feature and run the same framework for that new feature. And if you follow this framework repeatedly for every feature you develop for your application as part of your testing routine, it's a framework that's proven to let your team continually get faster, more reliable, and create a better experience. And so this is really a framework that's based on data and really following the data and really, having confidence in the data, that if the data says that there's a regression, your team takes it seriously and fixes it. Otherwise, you can move forward adding these regression safety nets with confidence that over time, nothing will get worse. And so this is really powerful. And this all starts with the raw data. So how does your team collect more raw data to feed into that regression safety net? So to begin to ask specific questions of your application, you need these inputs. So for example, the raw data could be logs, it could be anything you're collecting from your application. But we see there's really kind of two ways to collect raw data. The first is to instrument your application. And some common ways of instrumenting your application are to insert start and stop bookends throughout your application logic, where certain key events start and key events stop. So for example, and this can be done in any level of the architecture. So on the client side, if you have a certain user interaction that's traversing certain user elements, when you enter the start of that user interaction, you can log a start event. And when the action completes, you can log an end event. And by doing this on your client side, your backend, these start-stop bookends, you're actually creating a lot of metadata that you can use to ask specific questions later and find regressions. Additionally, another area that we see is really useful for instrumenting your application is to use regularly emitted system statistics from your application. And this can give you also a lot of raw data to make decisions. So if you have any telemetry on the application performance internally, on sort of connections to the server, on anything about your backend in terms of the throughput of your backend or the response time of your backend, these are really interesting statistics that can really start to suss out factors such as load and other factors that might not be measured, which can show up in these system statistics. And the great thing about instrumenting your application is that typically the instrumentation is left in from the testing app all the way to the production app with end users. And you can combine different data points coming from the instrumentation using time to create a common timeline. So for the approach of creating raw data by instrumenting your app, the positives versus other methods are you can get very specific to the application logic and architecture of your application by instrumenting your application. And it's very easy to get started. So typically you can just create a new API route where all of your systems, whether it's the client side, the backend, can start uploading data, and you can start immediately collecting this raw data where you can start finding regressions. The downside of instrumenting your app is really the data volume. Can be sometimes too much for in-app collection. Um, and also the data you might want to collect might be impossible to collect in-app. And it might be impossible to collect that data in production as well, whether it's because you're sensitive to the data volume of the end user, whether you're sensitive to the privacy of the end user. So for example, one of the data points that is difficult to get from instrumenting your app is just a video of the complete app experience. And so another way to address that, and what we really kind of focus on at Headspin, is instrumenting the test environment. So instrumenting the test environment is great because you can collect a lot more raw data from the test environment than you can from an instrumented app. And the way it works is you write special test harnesses when you run your manual or automated tests that capture additional data, raw data from the test environment. That can be the videos, the networks, audio, system statistics, code debuggers in terms of function call execution, instrumentation data, and more data depending on the platform. And you can combine these different data points by time. And so this is a kind of a fundamentally different approach to creating this raw data than instrumenting your app, because essentially you're not changing the app at all. You're putting probes into the test environment and you're pulling lots of raw data from the test environment as the test runs. And what's great about especially automated tests is regression safety net gets better and non-functional testing gets better the more samples you have. And automated testing is a really great way to create more data samples in more environments, because you can essentially retarget your automation into different environments and run it more frequently to get more data. And so the pros of the approach of instrumenting your test environment is that you can collect tons of data without worrying about the impact on the app. So you can actually collect potentially gigabytes of data, on every automated test, and not have to worry about, whether that app is, collectible or impacting your application logic. You can also move faster by instrumenting your test environment than instrumenting your app, because you can actually ask questions across different systems without having to coordinate with those system teams. And you can ask questions from the data without needing to modify or instrument the apps. The downside of test environments is that it's synthetic only. So this is only for running synthetic tests. These are not real users. So this type of regression testing does not carry to end users. This is purely synthetic. And one thing that's been really interesting that particularly Headspin's been focused on is really trying to bring the synthetic environment as close to the end user environment as possible, using real devices and real edges, for example. And what we find is that if you create a real enough synthetic test environment, it can closely approximate real users, and you can start to really combine the benefit of lots of repeatable data using automated tests with data that represents your end users. So when going down the route of instrumenting your test environment to collect raw data to drive non-functional testing, there are a lot of lessons learned, particularly when you look at what questions are you asking from the data and how do you analyze that raw data to pull out useful quantities, non-functional metrics that you can then use to make regression decisions. And so there's been some really interesting standardization in this space over the past decade. There's a metric called first contentful paint that is really a measure of if you have a web browser, or it applies to native app frameworks as well, although it's not natively supported. If you have a web browser, at what point is the first element drawn on the screen? So that's once all the CSS is loaded, all the JavaScript's loaded, when does that first element show up? And that's a really interesting example of how do you start analyzing raw data to create a useful non-functional metric. And so, for example, if you instrumented your test environment and you took a video of your browser running, you can easily look at the pixels of your video and figure out where the first pixel showed up on the screen. And so that's an example of, there are really different ways to approach it. If you're instrumenting your app, you might actually look at the JavaScript events and pull out when the first render event in JavaScript happened. However, if you're approaching it from an instrumented test environment perspective, you might capture a video of a browser and then look at when the first pixel in the video showed up. And you can achieve actually the same result using two different methods. You can do the same for other areas of your application as well. For your API performance, you can look at the time it takes for the client to connect to the backend, the time to the first byte from the backend to the client, the time to complete a total API request, your connection efficiency, so whether you're efficiently making connections to the backend. You can approach these from really two directions. You can look at instrumenting your backend code and trying to pull these metrics out. You can also look at instrumenting your client-side code to pull these out, or you can look at really just capturing network data as you run your test, and then pulling this data from that captured network data. The same for system performance in terms of frames per second, CPU and memory, and other rendering statistics. These are really important for certain types of applications, especially games. And you can really take the same approach here. You can, in your game, you can measure how many renders are happening. You can measure sort of the execution time of different functions or sub functions. Or you can look at it more from a system perspective and just pull off the frames per second and the CPU from the test environment and make decisions based on that. And then at Headspin, we've actually focused on a number of new ways, kind of extending this brilliant work with first contentful paint into new areas. So we have some definitions which are in our documentation called page load, user perceived quality, hotspot function calls, and loading animations. And so I'll go into a number of these examples during this talk, but of how do you actually take this raw data and start to pull out these useful metrics. So the first example is page load. So when you look at creating non-functional testing by instrumenting your test environment, there's actually two actors in the scene. One is you have your automated test script, which is running steps consistently. And something that's very difficult with automated test frameworks is actually getting precise timing from an automated test framework. So for example, you can submit an input action to an automated test framework, but you actually don't know when that input action executed on the framework. So it might be immediately executed within 50 milliseconds. It might take half a second to execute. And so with almost every automated test framework, there is this fuzziness when you can queue up an action to run, but you have no idea when it ran. And so when you're talking about non-functional testing, you're trying to get very specific answers. Errors of a second or half a second are actually very hard to run regression with. And so with non-functional testing, typically you want to get as perfect, pixel perfect in terms of a video as possible, in terms of how things happened for the end user. And so what we found is that you have your automated test framework, and then you have your team, which is trying to run the non-functional tests. The team can actually articulate clearly regions of interest where within these definite regions, there was a user action, and you want to quantify how long that user action took. And so this is an example of Wikipedia, where essentially I opened up Wikipedia app, I navigated to the search bar, I typed in a search, and then I submitted a query. And then at some point between submitting the query and the page fully loading, and then my automation running the next step of tapping around more and more screens, I know that there was a page load in there. I know that the query was submitted. There was a loading bar. The content progressively rendered, and then the page was fully rendered. And so as a team running non-functional testing, I know that there's a region of interest, which is bounded by when my automation submitted entered the search query and submitted the query to when I executed my next step in the user flow. So within that region, I know that the page was loaded. However, I don't really know how to measure that. And what we found is that kind of separating this idea of region of interest from the actual computation of the region of interest is something that is very helpful when implementing these non-functional metrics. And so, so this sort of two-step where you have your automation framework putting in input events, you have your team which knows the region of interest, and then you have some kind of data analysis that comes in and looks at the raw data and actually produces a pixel perfect result within that region of interest. It is actually a really successful framework we found for instrumenting your test environment and pulling out useful data from your test environment. And so how that's actually computed, how do you find within that region of interest the time that the page fully took to render? There's different heuristics and machine learning and expert systems that you can actually build. Some of them aren't actually very complicated. Some are more complicated. At Headspin, we've built out actually dozens of these systems, which can target these specific questions. But every system is essentially a data analysis project. So when you have a region of interest, you have to have your data analysis that goes in and looks at all the raw data, the video, the network traces, the debugger function calls. And using that raw data is able to piece together that data in a way that's confident it can put a bound on what the question actually is. And so we call this separation of region of interest to the actual time, quantified time, visual analytics. We think this is a really interesting practice as part of non-functional testing. And we see it something that, if you kind of adopt this as part of your regression framework, this idea of your testing team being able to ask questions of regions of the data and then having your data analysis answer those questions, it can actually lead to the really fast movement in terms of running non-functional testing and getting results. And so what we see is, for non-functional testing, is this can be most successfully structured really as part of the project team rather than as a specific function. So typically testing, might be a specific function, which is running functional tests. Non-functional testing is actually very successfully done when you integrate it as part of an existing product team. So for a product team that's building a new feature or maintaining a certain core feature, that team can actually integrate non-functional testing into the way that they iterate and the way that they plan sprints and milestones. And so a typical non-functional testing team really has three parts. There's the product engineering team, which prioritizes the architecture and implementation. One second. Excuse me. The product engineering team prioritizes the engineering, architecture, and implementation based on the non-functional metrics and regressions. So depending on, whether, for example, certain parts of the system might not be scaling with the load, or might not be scaling over time, or as your team expands to more geographies, the product engineering team, using this regression safety net, can actually prioritize architecture fixes to address those issues. The data team can extract measurements from the test data and collect raw data during the test runs and run regression against the baseline. So different teams might do this in different ways. They might grow this in-house where they have certain key questions that they know they want to ask, and they sort of build out as part of their data competency a way to measure and collect the raw data for those questions. And there are, of course, platforms that specialize in this as well, such as Headspin. And the testing team. So the testing team plans and runs automated tests in the instrumented environments using their existing testing framework. So for example, whatever framework they're using, the idea is to use the existing skill set of the testing team and the existing test plans, but get more value from them. So the testing team is already doing functional testing, using those same functional tests, bringing those tests into the regression framework as well, so that not only are they generating functional results, but then by instrumenting the test environment and running the measurements during the tests, you're also powering these non-functional regressions as part of the testing as well. And so that's really powerful, in that the testing team really isn't being asked to do another job. It's really about working more closely with the product engineering and the data team as part of this project team to not only run the functional test, but then implement a non-functional testing plan that works for them. And that testing plan will typically just follow the regression framework, but collect specific raw data and ask specific questions that are targeted for that project team. So I want to jump into a few examples before opening up for Q&A. So one example is in the gaming space. So for games, every different type of application, every industry or specific application might have different functional tests. And so this is really where you see a lot of different personas in functional testing. There's a lot of different raw data and specific questions that different personas want to answer about non-functional testing. In gaming, two of the ones that we see very popular are CPU and frames per second. And so if you have a project team that's focused on building out a new game, or maybe a new feature or expansion of a game, focusing on the CPU and frames per second would be a key non-functional objective, which you would adopt as part of your project team. So for example, an example team might set a baseline of 30 frames per second, and at most 50% of a single core on a mid-level reference device, and 15 frames per second and 80% of a single core on a low-end device. And so this is the baseline really that the team has set based on their internal idea of what a playable game is, and also really reviews that they've learned, which is there is a certain lowest possible playability as evidenced by reviews of a game and battery impact. And so by setting these objectives, the team can then collaborate between the product development, the data team, and the testing team to set up the tests and collect the data during those tests to measure these non-functional metrics. And so on every build, the tests run as usual, measuring the functional behavior, but then it also creates the raw data that the data team tracks the performance of the CPU and frames per second on each build, and they compare it versus the baseline. And so once that feature is ready for testing, and once it's in production, this non-functional regression actually can continue into production. So even in production, you can target your non-functional tests, the same functional tests, against the production environment, and collect data from, for example, a device running in the production environment, and measure whether there's regressions in the production environment. So this is actually a practice for this this product team that doesn't stop. It really continues as they iterate, as they evolve. They're continually running these non-functional regression statistics. And so, excuse me. And so this is this is really a practice that, when adopted, can be a key difference between an application going from 3 stars to 2 stars, or 3 stars to 5 stars. Is during that initial phase when things might be rocky, there can be key decisions made here about what to focus on. For example, certain devices, certain scaling of the backend is leading to a certain code that was pushed, or certain patches are leading to bad experiences. This non-functional regression safety net can really help catch that. So another example is for voice. And when implementing a modern application, typically voice input is a new concern, where many teams are starting to integrate assistants and understand how to take user voice as part of their application experience. And so the time to respond to voice input is actually a really interesting non-functional test. So during key screens, you might be able to speak to those key screens, and you expect the application to respond um, correctly and also within some non-functional time um, to those inputs. And so a team is building out sort of a new voice feature for an aspect of the product or a new voice product can adopt a non-functional testing practice and adopt this safety net where they can set a baseline, for example, at 500 milliseconds. And what's interesting is that this can be the baseline that they feel is correct for their users, or it can actually be taken benchmark from other applications in the space. And so, if, for example, you're an application that's entering a new space, such as voice, it doesn't hurt to just, see what other applications are performing and to kind of set your benchmarks based on what other applications are doing as well. So that when your voice assistant launches or your voice, controls launch, that they're as good as what people expect elsewhere. And this is a really great way to roll out new technology by really kind of setting these baselines to be appropriate for the space, so that when you come into the space, you know that you're running as good as everyone else. And so the way that you can implement this non-functional testing is to instrument the test environment to run something like page load analysis, which is what we talked about, which is from the time the voice input is spoken to the device to 10 seconds after that input. There should have been some change or some page load in the application during that region, and to measure how long it took. And what's really great is that because the test is automated, you can run as many permutations of input phrases using different locales as you want. And especially with voice, the device and the locale is extremely interesting. For example, a device sitting in a certain region of the world might actually be running different voice recognition than other regions. And so this is where synthetic testing can be really powerful. If you can, for example, run your tests in multiple regions by inputting different permutations of queries, you can really get a great idea of how your application is regressing and performing against your baseline. The final example I want to go through is streaming media. So this is becoming very popular, obviously, in applications implementing video on demand, live streaming. And for streaming media applications, there are some really interesting non-functional test cases. So for example, loading animations during video loading and also video playback, such as buffering animations, and video quality during playback are really key non-functional areas that teams focus on. And so, for example, a team might set a baseline to 1 second of loading a video, and the baseline quality might be arrived at by actually asking the team what are examples of good quality videos, that the team thinks are good. And what's interesting in the video space is that there's actually many different ways to arrive at bad quality. So it really depends on your encoder stack. It depends on your streaming technology and your CDNs to go, what are the edge cases that you want to test for? And one of the best ways to understand your baseline is just ask your team what are examples of good video and bad video that they've seen during their testing. And so once you've identified those baselines, you can instrument the test environment to identify loading animations and measure video quality. One of the other aspects of video quality that we found particularly useful is resolution switches. So understanding when the streamer switches from a lower to a higher resolution or vice versa, and perception factors such as blockiness and blurriness. So for example, it's very common that a bad video will have some measurable artifacts in terms of blockiness or interlacing, and being able to measure those with some perception factor is incredibly useful as part of the non-functional regression safety net. Additionally, reference-free quality measures that can measure live or original content can be additionally useful. Sometimes your team can use heuristics to build out these reference fee measures. And then sometimes you can actually work with partners who specialize in the video streaming space as well. So have about 5 minutes left. Before we jump into QA, I just want to mention a few resources for non-functional testing. So the first is our documentation at Headspin, which is the link here, ui.headspin.io/docs. We go into a lot of examples of how we run non-functional measurements of raw data, a ton of raw data that we collect in terms of what we think is useful for non-functional testing. In addition, Headspin is a real edge synthetic test platform that lets you run your non-functional tests in real environments. We have a training for all teams that want to get better at automation called Headspin University. So ui.headspin.io/university. There's a group course where you can join and get mentored into implementing automation on your team. This also just recently launched on LinkedIn Learning, where you can find us under Introduction to Automated Testing on LinkedIn Learning. And then the Mozilla Developer Network has some great content on non-functional metrics such as first contentful paint. Thanks for the opportunity to present today on non-functional testing to guide your user interface, backend services, voice, and media development. This is a very rich topic, and would love to work with anyone here and answer any questions. And hopefully, if you're interested in this, would love to connect offline and go deeper and show you Headspin and or help your team get started with non-functional testing. Thank you very much. Open to questions.
All right. Thank you very much, Brian, for your presentation. This is some really interesting stuff. Yeah, there are some questions in the chat. I will just go ahead and start asking them to you. The first one is from Jacqueline Schweigert. She asks, what tools and frameworks are you using to conduct non-functional tests?
Great question. So we actually see Appium as a really great start. The Appium community has started to adopt some non-functional data collection, such as collecting videos, collecting logs of the test runs. I think the direction of Appium is really good in that it lets you target your automated tests to different environments, which helps you collect more data for your non-functional tests. In terms of the data analysis, there's some really great ways to get started with Python for your data team to start to measure, for example, pull in the test video and match different waypoints in the video to start pulling out non-functional metrics. So that's a really great way for your team to get started. There's also ways to kind of really start that up faster using commercial services, which happy to connect on that offline. Thank you.
All right, thank you, Brian. Another question from Gaurav Mathur. How do you conduct non-functional testing today?
Yeah, great question. So it really starts by using what you're doing currently and making it, as part of a more collaborative effort with the product development and the data team. So every product team will have a goal, which is, they're trying to build some new feature. So as part of that, it's to identify what are the non-functional metrics that would help you catch regressions and make sure that you create an amazing experience of that feature. And then to go and collect the data during those automated tests and pull out specific questions during those automated tests to track your progress towards that goal. And so we see this very repeatable across the industry, which is all the clients that we work with adopt a very similar framework where essentially it's adopted as part of their product development lifecycle, where non-functional testing is more of a product development process rather than a specific testing function.
All right, thank you for that answer. I hope it answers the question of Gaurav. One last question from the audience for the moment. If you to the audience, really quick, if you still have questions, you can ask them ahead. I will pick them up. All right. Well, the last question for the moment is by Robert Wernhardt. Nice view so far. What is your take on Microsoft Application Insights? Do you know it, and what's your take on it?
I'm not familiar with that, but I really love these. If it's an instrumentation framework, I really love instrumenting your application to pull out more data. I think it's incredibly useful and powerful. So if it is an instrumentation framework, I highly recommend starting there if you can with non-functional testing. Typically, what I find is that to really integrate non-functional testing into new projects, rather than having them sort of change the way they write code or going through an approval process for a new SDK, it's actually easier just to instrument the test environment. So that's really what I've been focused on for a while. But I think if you do have the buy-in or you already have something in place to do the instrumentation, that can be one way to start with non-functional testing, and I would recommend that.
All right, thank you. And Stefan Fischer asks if you can put some links in the chat for some of the tools you mentioned.
Sure.
You can do that after the video. But to Stefan, Brian will put those in here. It's not a problem. And there are no more questions from the audience. Oh, yeah, we have another question from the audience, from Alexander John Anakar. He asks, what's the runtime of your tests? Are you executing them on every build in your CI/CD pipeline?
That's such a great question. With non-functional testing, there's actually two ways to do it, and these two are complementary. So one is, as during your existing functional tests, just double purpose your functional tests to do non-functional testing. So when you have a new build, you're running functional tests, collect your non-functional metrics and run regression right there. And if the non-functional metrics detect a regression, just fail the build. The other is to run them on some regular schedule in production. And so, for example, every day, every hour, you can run your non-functional tests against a production environment to actually measure how those metrics are, those non-functional metrics, such as time to search or time to load your app, or time to play video, how those are changing in the production environment. That's also incredibly useful. And both of those really feed back to the developer team. So the developer team that's working on that particular product area knows not only before they release is everything good, but then also after they release that everything's trending in the right direction.
All right. Now there are no more questions from the audience, but I do have one question. How would I go about testing the performance of, let's say, a WebSocket function that I have? Are there tools that are specifically good for WebSocket things, or how would you go about that?
Yeah, great question. So what I would do is actually pull out stats from the client side during the test. So for example, in the Chrome debugger, you can pull out a bunch of network stats. During your test, you can actually just connect to the debugger and pull out statistics about your networking behavior. You can save those statistics as part of your test as basically a separate file. So you can pull out connected to this WebSocket, receive times for every message, and you can actually use those statistics to ask specific questions of your API. In terms of the specific questions you're asking, typically what we see is really focusing on what we call bursts of traffic. So for example, when you're loading your application, you're probably going to be doing a lot of asynchronous messages.
Yeah.
You probably want to measure from the time the application started loading to when it ends, the total time of all that network traffic together, because that also factors in the time it took to parse the network traffic and then make additional requests. And so this type of network analysis, I think when you look at sort of the traffic in aggregate and track an aggregate time from time to first message to last message for a particular user action, that's very useful.
All right. Thank you for your answers, Brian. There are no more questions in the chat. So I would say thank you a lot for your talk. Thanks a lot for your answers. And also, as always, thanks to the audience for these interesting questions. I wish everyone an amazing time with the last talk of the day, which is going to be by, how was he called again? Chester Santos. He is an expert in memory training, and he will show us some really cool tricks about how to memorize some things. So I think that's going to be really interesting. Hang tight. 10 more minutes, and in the last section you will meet him. Thanks again, Brian, and I hope everyone is having a nice rest of their day. Have a good one, everyone.
Thank you.
Bye-bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.